Hey everyone, I'm Alex from Porto, Portugal, and I am attempting to solve all the LeetCode problems. So I'm going to post each problem on YouTube. I'm going to make a video showing how I did it. So far, as you can see, I've done 99 problems, and I'm going to go over them as well. I'm going to solve them again, but then I'm going to solve each one like on the video. So I'm not going to see it before. I'm going to live stream my solution or my thought process and everything. So difficulty, easy. Yeah, this makes sense because if I remove this, then we get a 1, 2, 3. So I'm going to start with all the easy ones all the way to the end. Then I'm going to go for the medium ones and then the hard ones. I think that's the best principle if you want to evolve. Yeah, but if I decide to change that in the meantime, I'll just let everyone know. So let's start with the first one. Before all of that, so LeetCode. I already solved 3 of them because I was getting ready for this yesterday. So I solved 20, 21, and 26. But I'm going to solve number 1 now. So the directory 01, I should start with like 0001 because I think the total number of problems is 2000 something. Let's just do this for now. 0, 1, 2, sum, and change there, and touch solution.py. So solution. And here we go. Okay, this is good. I don't need folder. So to sum. I'm not sure if I'll have something here that I've done before. Oh, I don't. Great. So let me copy this. So, by the way, I'm going to solve everything in Python and using type-safe Python. To sum of what? So, given an array of integers, let's see, maybe I need to zoom on this. Given an array of integers, nums and the integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so if we want 9, 2, 7, 11, yes. Okay, the arrays are not sorted, as we can see. But maybe if we sort them, we get an advantage. So, do I have Paint on this laptop? Yeah, so what I'm going to do is, well, the easiest solution, let's say we have a list like this. Let's increase it. We have this. And you just do a for loop, like you start with 1, and then at the same time you start with 2, and then you go for 3, 4, and you check if the sum of this one and this one equals the target, and then you go all the way to the end. If it doesn't, then you start with 2, and then you sum 2 with 3, 2 with 4, and all the way up to summing 5 with 6. And that should work. That's like the dumbest solution. But let's just try this one. Let's start with something simple and then let's optimize it. So the input is nums and target, so we can do this. Yeah, I could have just deleted. Sorry, let's see if the formatting is working. Oh. Format document. Windows. Okay, working. Okay, so now what we need to do is for left number index and left number, because I'm going to sum the left with the right one, as I showed here. Fine. The black one's the left, the orange one is the right. So left number, right number, and enumerate nums all the way up to the second last one, because we want it. We want to sum 5 with 6. We don't want to sum 6 with 6, so might as well end here. So enumerate, if you don't know, it returns the index that we're going and the actual value if we're iterating over an array, which is pretty useful. So let's pretty much do the same thing for, and let's switch left with right. Right number in enumerate from left number index plus 1. Let's not forget it starts with 0. All the way to the end. And what we can do here is, I don't even think we're going to need this. So if left number plus right number equals target, what do we do? Output 0, 1, because we want to return the indices. So yeah, this is going to be helpful. So we return left number index, right number index. So yeah, let me just print this, see if it works. Zero, zero. Shouldn't work like that. The target is 9. Oh, yeah, I get why this is not working, because the enumerate. Okay. Yeah, why this is not working, because this is using a subarray, and then it's going for the index of the subarray, not the index of the original array. So what we can do is, if if right number is lower or equal than left number, indexes. Continue. So I guess that if we do this right now, enumerate nums of left number index. Yeah, we don't even need to do this anymore. Yeah. So 1 and 0, 0 and 1. Huh. So the left number is 7 and the right number is 2. It's just weird. Yeah, of course. Yeah, sorry guys, like used to working with the English keyboard and now I'm using a Portuguese one. So I get these kinds of mistakes. So this is 2 plus 7. Okay, so this works, I guess. Yeah, 0 and 1. Let's try the other thing. The other input. Just gonna remove the breakpoint. 1 and 2, 3 and 3, 0 and 1. Zero and 1. Okay, I think everything is working. Let me just submit this and see if it just passes. might not work for all of the solutions. Okay, yeah, it got accepted, so it beats everything. So December 2022. Okay, runtime. Okay, I've done better. And why did I do better? So let's first of all sort the array. What I want to do is I don't want to do sums that I know that are going to fail. So let's say if the target is 3 and we reach this thing here, and this is a sorted array, we know for sure. Well, wait a second. Yeah, if the target is, let's say, 5. Okay, this is not a good example because we have all the numbers sequential. Okay, let me do another example. So if we have, let's say, 1, change color, increase size. 1, 5, 6, 21, 340, something like that. And then it goes on. And the target is the number 11. That's the target. So we start with 1 plus 5, which is 6. No, 1 plus 6, which is 7. No, 1 plus 21, which is 22. And we're like, oh, 22 is over 11. So if the array is sorted, then we know that 1 plus whatever is next is going to be higher. So that's not really like the thing that we want. So let's move on to 5 plus 6, which is 11. So we skipped 1 plus all these others. So we start with nums.sort. And as we see, this returns none, which means it changes the object itself. And now, if we can do elif if this is bigger, sorry, if this is bigger, we can break this cycle and it moves on to the next. See if this works. I should run this code. Probably messed up, but maybe not. Didn't want to press this one, wanted to press submit. Okay. 324 02. Oh yeah, right. Because oh god. Now that I sorted it, I don't have the original uh indices. Okay, so now that I'm doing this, what I'm going to do is I'm going to create a dictionary, index dict, which is a dictionary of integer and integer. And what is this going to do? This is going to save the index positions of each value. So now, unless we have repeated ones, oh god, this sucks. Um, okay. Okay. List of integer. Okay, so for num in nums, num index, and num in enumerate nums, index and okay. If not, if num not in index dot keys. I didn't have to use dot keys, but I want to do it just to be obvious of what I'm doing. So this one, we know that the number that we're doing, I don't want to do this like right here. I want to create just a empty array. And now we just say, let's append the index. So now we're here. Okay, we have this. So now we know that these numbers are good. So we just do this. If left number is equal to right number, we know that we have two indices. We can return index of left number 0 first position and then second position. And if not, we can just return left number 0 and right number 0. And now this probably has an error. So let's see. Ready for me? Okay, it worked. Let's just admit. It's trial and error. Always. Oh, accepted. And it's funny, because now it takes even longer and uses more memory. So I wonder what I did back then. I probably went and read a solution. Let's see. Yeah, I was like, I probably didn't write a solution that ran inside the time limit. So I went and copy pasted one of the solutions, which is interesting to see. So to some hash table for all the numbers complement target minus n. Oh yeah, this is interesting. So what this is doing, it creates an hash table, so dictionary, and now it iterates on the numbers, and then we see target minus number. So if it exists already, then we just return that. If not, we add it. Oh, this is actually pretty elegant. Yeah, we don't need to sort it. Actually, you see that if we sort it, we just takes longer, because sorting it also takes its time. Okay, wow. Okay, this makes sense. So yeah, but anyways, this is how I did it right now. Not the best thing, but let's keep going. Thank you for watching.